And I'd like you to tell me, the work that you've done, a lot of it is about understanding. So it's either about AI understanding human work, humans trying to understand the intent of AI, or in Qian trying to understand how humans understand the output of AI. So what I'd love to know is, what are your dream applications of this work? What is the thing you would love to see your work end up doing for people? 30 seconds, it can be as bold as you want, and then we'll close up and move on to Werner. Phil, do you want to start off?
Yeah, I can sort of, okay, 30 seconds. So in the best case scenario, our system is able to take any sort of text, whether it's a poem, something you've written yourself. It could even be a news article, and create a visual representation that is more easily maybe to understand for people without losing the key semantic features. And then people can share these insights, across different cultures, across different languages, and, give them a way of like sharing maybe a more accessible or more even emotional way of discussing certain texts or something like
Joao, is that your same dream for the work, but with more blended emojis, presumably?
I'm actually more interested in having a system trying to help the user, for example, in Brainstorm. I mean, this has been more or less my idea for the work I've been developing. And here, you mentioned like these alignment from what the system understands and what the user understands. And you have, I mean, obviously you can try to align these understanding, but then you can think, does this also happen when, for example, you and me would interact, and maybe these misunderstanding between us would allow us to reach something that we wouldn't if we understand each other perfectly. So also this misunderstanding is also a great space to probably explore.
I like that very much. Qian, you had a great example of kind of a concept poster in your video, but is there any other kind of dream applications you can imagine for the kind of work that you're looking at?
Well, you asked me to try to inspire the audience, so I'm going very far. So my research showed that people normally favor realistic renderings, which means from an evolutionary psychology perspective, they favor the proximity of the expected. But there are also abstract renderings which are favored by some people. Now, my dream would be that could we configure and automate neural style transfer in a way that it can produce many different variations of abstractions, which then people start to like more. Why? Because abstraction in an evolutionary psychology perspective means they are strangers, but not complete strangers. So we start to like them. And that actually would create more openness to people. And that in a very, very long-term sense would maybe also decrease maybe biases, like racial biases.
Wow, that is big stuff for sure. Okay, Louis and Thomas, you've already done amazing applications with your work with artists, but are there any dream things you'd like to do?
Well, generally, we'd like to foster reflections about our uses of machines, because of the impressive progressive of AI in the last 10 years, people become fascinated by the tools, and they are not using anymore these as tools, but they are like clicking on a button and being impressed by the production of the machine. And in this work, we wanted also to point that this is, of course, fascinating, but moreover fascinating as it's used as a tool in a general process, and in general in our everyday life with machines. We'd better use them as tools to catalyze us in our creativity, in our possibilities, rather than just pressing the button and being fascinated by, of course, this marvelous possibilities that are offered by these new techniques. So this is a bit our dream, to have people thinking about our relationship with machines and what do we do with them. Do we just click a button, or trying to bring it in our creative loop generally?
I think that's wonderful. I think there's a lot of people at this conference who'd feel the same way. Okay, thank you, Phil, thank you, Joao, thank you, Louis and Thomas, thank you, Qian, thank you to the audience and to Luca and everyone behind the scenes. And that's the end of the visual creativity session. Thanks very much.
Thanks a lot.
Thanks a lot.
Bye-bye.
Bye.
Hi, everyone. I would like to welcome Emilia Gomez to the International Conference on Computational Creativity. Hi, everyone. I would like to welcome Emilia Gomez to the International Conference on Computational Creativity. It is a pleasure for us to have her with us. It's a pity we can't have her in Coimbra talking and having some fun with us, with all this great community. But sometime later, we hope we can invite her again to come here. Emilia Gomez will talk about human and machine intelligence, music information retrieval perspective. She works with the Music Technology Group in the Universitat Pompeu Fabra and with the Joint Research Center in the European Commission. Emilia works mainly on music information retrieval, and using her own works, she tries to understand the way humans describe music in terms of melody, tonality, similarity, style, or emotion, and emulate these descriptions with intelligence systems dealing with large data sets. She is interested in studying the impact of AI on how we work, our decisions, creativity, and children's cognitive and social emotional development. She is and has been involved in several European projects like HUMAINT, Human Behavior and Machine Intelligence, that is running, still running, TROMPA, towards richer online music public domain archives, also a running project. And in the past, Phoenix, changing the way we experience classical music concerts, well, and many others. She will speak about her own research. So, Emilia, thanks for being with us. Let's listen to you.
Hello, my name is Emilia Gomez, and I'm honored to be here with you virtually at the ICCC conference to talk about my own perspective on the balance between human and machine intelligence from my research experience on the music information retrieval field. Let me start by introducing to what is music information retrieval and which is the kind of research that we do there. After this general introduction, I will explain which are the main challenges and research topics that we currently address. I will illustrate our technologies by giving you some practical applications and also some demos of some of the things that the field is doing. And I will end up by talking about the social and the ethical implications of our research. The motivation of the music information research field is current access to unlimited amount of information in mainstream in streaming services about music, and in fact, it's very difficult for a human being to make sense of all this music content, and so that's the main goal of the music information retrieval field: try to build technologies for understanding music at a large scale. I have been part of the music information retrieval research, MIR research, for more or less 20 years now, taking part at the International Society for Music Information Retrieval, the ISMI Society, which is a well-established research forum now, which has high both academic impact in different areas of research, in different disciplines, and also very strong industrial impact between we haven't already commercial products out of our research. In my particular work, I have mainly working with audio signals, which and the main goal of my research has been to extract automatically extract information or meaningful descriptions from music audio signals. So the three main goals is to first try to understand the criteria that human beings use to describe music. Second, to model those human descriptions by algorithms that we program. And doing that, we try to integrate knowledge from different disciplines for music theory, music cognition, and so on. This emulating human intelligence, in fact, one of the goals of the artificial intelligence, or the main goal of the overall artificial intelligence field. By addressing this goal, we have been trying to extract what we call music features or music descriptors automatically. For instance, we can now describe audio files instead of pitch or melody, which is a very important musical concept, which tries to represent music by a series of notes or a series of frequency values. We have been also addressing high-level musical concepts, such as the concept of chords, or musical chords, or musical key, or tonality, by incorporating knowledge from music theory or musicology. We have been addressing also the temporal evolution of music, for instance, repetitions, temporal changes, which is related to the concept of rhythm and repetition. We have addressed also the topic of similarity, how to compare two musical pieces and see how similar they are. This is a concept that is key for recommendation, for retrieval. For instance, trying to retrieve different versions of the same song. And finally, by incorporating information or features about melody, chords, rhythm, also with other more high-level or context information, even information that is found in lyrics or in metadata, we can address high-level concepts such as the concept of musical style or music emotion. This is more or less the task that we have been addressing in the MIR field. Traditionally, to develop algorithms, we use the approach that is called feature design approach, where we first, and this is represented in this plot. In the left, you see that first we gather some music material. That was, in my case, it was mainly audio material that was representative of the problem we want to address, that was varied. Then from this material, we collected human annotations, maybe following strategies for music cognition, and we involved human subjects. And after that, we were trying to emulate those human annotations. So we were developing algorithms. By comparing algorithm output with human annotations, we could evaluate how well our algorithms did the work. Over the years, we have been incorporating here this connection, learning some aspects of human annotations to fit our algorithms, and also seeing these distant metrics as a function we should optimize and, of course, we should minimize. This is, in fact, part of the machine learning world, which is a subfield of artificial intelligence, where we try to give computational models the ability to learn without being explicitly programmed. Machine learning, and in fact, I've been mainly working on supervised learning, has been the main approach to address many music information retrieval tasks. In this figure, you see an example of supervised learning block diagram for music emotion recognition adapted from a work that was addressing also other or other tagging activities, where we see that you have the learning process from features. We extract some features, and the machine learning models learn features, links feature with annotation, manual annotations to train models that are later evaluated on new data. Supervised learning is very general, and I'm sure most of the audience know of its application in other areas of work. In our case, in music, it has been applied to classify music in terms of, for instance, musical instrument recognition, in terms of music emotion. So try to classify music in terms of sadness, happiness, etc. For the classification and recognition of music styles, for instance, to identify if a music piece is classical, jazz, pop, or rock, and even to classify or identify preferred music. For instance, some work we did on trying to classify musical preference and automatically. Over the last year, the supervised learning approaches have been also addressed by using a particular series of techniques, which are the learning architectures. I am sure that some of the audience will be aware and also of deep learning architectures that have been applying to almost all areas of research in computer science. In the music domain, they have been applied for music description, music processing, and music generation. And this is illustrated by this plot from Jordi Pons that illustrate the number of papers and until 2015. After that, almost all approaches are based on deep learning techniques, which initially learned from some high-level representation of music, for instance, musical notes, later from lower level representations like spectrogram, time frequency representations. Finally, even they can learn some tasks from raw data, raw audio signals. Deep learning techniques have been virtually applied to all the MIR, all the music information retrieval tasks. We can revise our original schema of music information retrieval to emulate human intelligence, and we have seen that in the field we can see drift from knowledge-driven to data, what we call data-driven design. That means that the parts of understanding strategies for humans to describe music has been a little bit not put much effort into that, but there is a huge effort into more this data modeling or modeling data that comes from human descriptions. And it is said that in our field, the interdisciplinary knowledge is not currently in a focus, but there is more an engineering focus of our research. Let me illustrate that with a practical methodology that we follow for MIR tasks based on deep learning. This is an example of a paper we are publishing on the multiple pitch estimation in vocal ensembles using convolutional neural networks. And where the architecture is depicted in a figure, and you see that we work a lot on data gathering annotation, on trying to see which is the best input representation for our data, which is usually time frequency representation. In this case, is the CQT magnitude and phase information, which is very very suitable for melodic kind of features. We try to design convolutional networks and architecture the neural network architecture, which is much fits our purpose to have this input processed by the architecture and have an output silence, which is then post-process to have our features. And it's important also to work a lot on the training testing methodology that we use. There is a discussion that there is a graph or difference in motivation between artificial intelligence techniques or with the goal to emulate human intelligence towards machine learning models that were most used on handcrafted features, which somehow coded some knowledge we had about music through towards deep learning approaches that mostly can be applied to any data. It doesn't matter if it's music, images, or whatever. But there is a discussion about this difference in motivation that I illustrated here in the slides. But there seems still that deep learning methods have really improved on all these tasks, but that have really solved the problem. But there are still some challenges and some problems that we address mostly in the deep learning area. And I wanted to illustrate 3 or 4 of the challenges that I think are more relevant in our field. The first one is the relevance of data. Data has become crucial to have high accuracy in research and also have high result or better results in research. There is a need for a high amount of data of the different tasks we address. The data should be of high quality. It should be representative of the problem we want to address, and it should come with human annotations. There is a lot of challenges that we need to address from the research perspective on data gathering. First is the privacy and issues related to and the copyright protection, and this is especially music a problem when we want to share the music data. Privacy also of personal information, for instance, of annotations, which makes it difficult for academics that are not doing research on a certain product to have private data or personal data related to music. There's also a challenge of methodology. There's no common methodology for data sets, for developing data sets, so it's difficult sometimes to integrate, for instance, to integrate data sets from different sources. There's a research effort on interoperability of data sets. And finally, there might be problems in the bias we have on the data because the data represent reality, so there is a sampling of the reality and we should overcome this bias. But still, there's a huge effort that our team and or our community does in the building data sets and also publishing those data sets for research. As an example, this is the last data set that we published. It's a data set for choral singing, where we try to get multimodal information. So we publish audio files, recordings of people singing in different microphones types, but we also annotate this with manual and automatic annotations. So manual annotations in terms of rhythm, in terms of score alignment, and also computer features that we can attract. It's important also that data that does not come alone, but that also comes with toolbox that make it accessible and easy to use. In our case, we develop a Python toolbox that is accompanying the data set. And in order to make the data set accessible not only to computer scientists, but also to people from other disciplines, for instance, musicologists, we have a visualization interface that make it also accessible and easy to grasp. So it's we needed to make also accessible for different audiences. Another kind of research related to data that we carried out is to work a little bit on human data gathering. As an example, wanted to put the Trump project, which is an European project where we combined human and machine intelligence to build better music systems and to make better open data. And in this project, where we try, and this is illustrated as an example for music emotion recognition, we want to have data related to how people perceive emotion in music, to train our models and to do the research on music and emotion. And on one hand, we want to get human data, people data. On the other hand, we want to offer people something on exchange. So we develop technologies for the recommending music according to emotion, and also for learning about the link between music and emotion. So this is a link where you can access our prototype, where you can become active in the citizen science approach and help us for our research. The second challenge, in addition to data, is, of course, computing. There is a huge need of computing power, and computing power is being a key driver of research and a key component of successful research. Let me illustrate that with this example of OpenAI Jukebox system, which is a music generation system based on deep learning that use very large number of GPUs. Larger GPU or number of GPU availability is a key to build larger deep learning models. And of course, the fact that they have an amount of computing resources allows for smarter and also for very good quality research. The challenge, of course, is the cost of these computing resources that creates some inequalities between small academics and also large labs and corporations. And there's interesting research challenges related to compute that, for instance, the trade-off between accuracy and scalability. Let me illustrate this trade-off by some work that we are currently doing, and is led by Furkan Cesiler at Music Technology Group on the task of version identification. That means the discovering of the versions of the same song, where that is trying to address the traditional limitation of systems which are either fast or accurate. For instance, some cover identification systems that were created, they were not scalable to be applied to large music collections. Deep learning systems allow new areas of research on the accuracy scalability plane that we have also illustrated in this graph here, in having high accuracy but having also high scalability. In our work, we explored the use of embedding distillation techniques to obtain reduced embedding size, so to optimize embedding size, and this allows us to have less storage space, also suitable for large data sets, to also speed up the retrieval process, and also to keep our accuracy, even have slightly better accuracy, but have similar accuracy that traditional system. The third challenge, in addition to data and computing, is subjectivity. Humans have individual opinions about concepts. This is a property of human intelligence, but still machine learning or machine intelligence present majority views. They perform overall or average classification. But many music concepts are subjective, and we need to address that also in our models, and also address this in our approaches. In our research, we address this issue by building and studying personalized models, personalized to individuals or personalized to certain groups. This is an example of the work by Juan Gómez Cañón presenting this year at ISMER, which in the task of music emotion recognition, we have seen that there's if you analyze the current music emotion data sets, there's a low agreement in the data sets if we have several annotations by actors. In addition, there's substantial difference in the annotations across listeners, and we have focused on listeners that have a different native language. So we observe that there's a difference in the agreement of the annotations. You see here at the right an example of group-based annotations of the percentage of agreement for different emotions. But we observe that if we perform instead of overall or average annotations, group-based annotations, we can consistently improve the classification accuracy. So this kind of work is very connected to music cognition studies and open up new research path on personalization and also on the understanding of agreement in music. Other interesting challenges we are currently addressing and are general also for other fields of research, not only for music. And I wanted to point out maybe 3 of them that are already presented in the paper that I said below by Lake and co-authors on the difference between human intelligence and machine intelligence. One of them is that humans have a priori knowledge of concepts. They learn from few examples, while traditional machine learning models need to be learning from scratch, and they need a high amount of data to learn. Our community is addressing that through different research topics. For instance, unsupervised learning. So we need we don't need manual annotations. It's a current advantage, and the pre-training and fine-tuning on models, zero-touch learning, and also the combination of not deep and deep learning classifier. As a second interesting challenge derived from human intelligence, that people learn models and then they use them for new tasks and goals. And while models are usually task-oriented, the research currently tries to advance on multitask learning, for instance, in music, learning at the same time concepts such as rhythm and melody and emotion and style, and also transfer learning, for instance, from the domain of speech to the domain of music. There's some words that try to make use of transfer learning from one domain to the other. Well, the last challenge I wanted to mention is that people can explain which is the criteria they follow to generate music, to annotate music, while machine learning have traditionally a black box character, and there is some efforts in the community for more transparent model and explainable, which can overcome this gap between knowledge and machine learning models. After introducing the challenges, even though there are still many things to improve into current MIR techniques, there are already some applications that are possible to carry it out. And I wanted to give you some practical outcomes, and then to make a little bit and make it more easy to understand. I will make some demos and some applications. The most well-known application of music information retrieval technologies is music recommendation. You may all have experience with music recommendation systems such as Spotify, Deezer, Amazon Music. I mean, there are many of those services that nowadays, so I won't make any demo of them, but you know that those systems integrate music information at different stages for recommending music based on similarity, based on novelty, and other kind of concepts. And I wanted to just bring back to you that music recommendation can be used for other purposes. One is music therapy. We have been working for some years in a project for music recommendation for Alzheimer patients based on the music of their life, the music that might bring their memory and connect it to our work in music and emotion, which allows also to address some of the challenges of building music recommender systems for different audiences in different contexts. Another example of applications is the use of music information retrieval in music concert. And the Phoenix project was an European project that took part some years ago. And we tried to use those technology in the context of concert to enhance music content experience before, during, and after the concert. I will now play a video that illustrates how music information retrieval technologies can be used in the context of a classical music concert. In addition to description, those technologies we have research also how these technologies can be also applied for transformation. In this case, I will illustrate that with an example of a source separation technique, which tries to, from a musical mixture, try to separate the different instruments that are playing. And from this separation, they are emphasized for an application of music focus. And I will now play this video. Another interesting application that has been very well known during the last years is the use of those models for the generation of content. In particular, different companies have issued, and also in the academic world, we have been having works and approaches, and some of them are also published at ICTC about music generation based on deep learning. In our case, we have focused on the singing voice, and our lab has at the Music Technology Group has published some papers about singing synthesis. We have a project also in collaboration with the Yamaha. And to illustrate this application, I wanted to play you a video of a work that the Yamaha did on to reproduce the singing of the legendary Japanese vocalist Hibari Misora, and I wanted to illustrate with that also music combined also with some work on generative models can be, and also to illustrate how this can be a real application in a real context.
夕日がまた沈んでゆくあっという間の一日どこかに大事な何か置き忘れたような自分の壁視点線は変わらないのに静かに映る景色生きるというのは別れを知ること愛しいものあれからどうしていましたか私も星を取りました
Now I will finish up my presentation by discussing on the socials and ethical applications, because we have seen that those applications are currently used in the real world scenario. So it's very important to analyze which are the social and the ethical implications of our research. First, I wanted to address the topic of bias, fairness, and discrimination, and one of the main challenges that we need to do research on. Humans have biases, systems have biases, data also have bias, and those systems perpetuate those biases. I illustrate that with the work by Sungwoo Tonan and Ricardo Baeza to different ways that we can incorporate bias in our system. We do some research on bias, fairness, and discrimination in music. In particular, we have focused on the exploring gender bias, because research has found gender difference already in music industry. And the bias of music industry is present in the data that we analyze and that we exploit for music recommendation. So we wanted to know if the music recommender systems are really driven by those biases. And this is a work that is made by Dougal Shakespeare and Lorenzo Porcaro in a master thesis. And we see that, of course, we need to do more research on evaluating bias present in data, evaluating the bias introduced by the algorithm, and making sure that our systems are not reinforcing existing biases. The second aspect I would like to discuss about social implication is transparency, and we discussed that in a paper together with Bob Stern, Maria Iglesias, Owen Tal, and Marius Miron, because the fact that there is now realistic music generation, realistic singing, made us ask if we should inform listeners about the presence of artificial intelligence systems in the music they listen to and the music they consume. And we try, of course, for that we need methodologies for transparent design so that we can document where in the process or in the tools that we use, where in the tools that we develop is automated systems are involved. Another aspect that is important to mention in the social and ethical implications of our research is the authorship. Traditional owners of music creations have been the composers, the writers, the musicians, the singers, and the phonogram producers. And this will be still the case because artificial intelligence are designed as tools that are just assist those human creators. However, the current trends or the current idea that we could sometimes generate full autonomous AI systems might need that we need to incorporate other actors in the authorship process. For instance, the people that create the data, and there is here a tweet that was referring to the people that create the original recordings that we use for learning, the data set curators and the people that design data sets, and also the developers of the algorithm. Another aspect that we discuss in our paper and in our work is the impact that AI system may have on jobs, because in most occupations related to music, we perform some tasks that could be partially or fully performed by current systems now or in the future. And this implies a transformation of the occupations and also of the skills of workers that we need to promote. Let me illustrate that with some work that we have been doing together with some colleagues in different places, and in the paper that you see there about the mapping between labors and occupations, for instance, creative and performing artists, the mapping of the tasks that they do at work. For instance, they do some creativity and resolution. This is some data that we have from labor markets and from labors and occupations. We map them to the cognitive abilities that they require to perform the different tasks, for instance, communication or text comprehension. And then we map these cognitive abilities to different AI benchmarks that are addressing them. For instance, some AI benchmark might be addressing text comprehension or quantitative reasoning. We try to somehow compute an artificial intelligence exposure score for the different occupations. We still see that there's the creativity part that they involved in the creative occupations is not addressed by current AI research field, but might become also addressed in the future. So we need to better understand the impact that it has on the jobs. Finally, there's a huge impact that those systems may have on human behavior, and we need to research on the best collaboration between human and AI interaction. We do in the context of the human project some work. For instance, we do some work on child-robot interaction, but in particular in music, we have been collaborating with two artists, a composer, Richard Pettifer, and Thomas Pasquale, on an opera, which is called My Data and Me, Una Storia d'Amore. It's this opera addresses the new engagement between human and non-human. Then this opera, there is one of the characters, there's a love story or love affair between a human being and also a robot. And then we try to address in an interdisciplinary way, involving artists and involving also scientists in this interaction between human and AI agents, and also on the impact that our technologies may have in future human behavior. As a conclusion, we have seen, and I hope I illustrate the current shift that music information retrieval technologies may have had from knowledge-driven to data-driven system. This is bringing new challenges, not only from research, not only in technical research, but also in interdisciplinary research. And the current advancements call also for more insights and more research on the impact these systems have on us. And I wanted to end up by quoting a paper by Carmine Emanuel-Sella that it's called Music Information Retrieval and Contemporary Classical Music, a Successful Failure. And his words on the paper saying that I think that we should never allow an algorithm, however powerful, to replace our knowledge. We should instead integrate it with our knowledge. the result alone is never the answer, the acquired knowledge is. And this is an inspiring paper and a quote that I wanted to make to conclude my presentation. So I hope you had enjoyed my talk and you had some more knowledge about the music information retrieval field and the challenges we currently address, and that you have a good and you enjoy the rest of the conference. Thanks a lot for your time.
Hello, Emilia.
Hello,
Nice
everyone.
to meet you.
Nice to be here. Thanks for the invitation.
And thanks for accepting and making this effort to join the conference. First of all, I forgot to mention an important part of your curriculum. You were until recently the chair of ISMIR, the International Society of Music Information Retrieval.
Yes.
Sorry, I missed that part when I presented.
Don't worry.
When I introduced you. Well, now we invite everybody to write questions in the Q&A tab in the main stage, in the main room of the conference. But while we don't have questions, I would like to put one to Emilia. I think it was some examples that you presented on the use of deep learning techniques in real time to visualize what is happening in a musical performance are amazing and very inspiring. Well, the tendency is to have more and more AI techniques involved in the artistic practice. We know that. So in our conference, we have been discussing a lot. One of the key topics of the conference is co-creativity. When humans and machines collaboratively intervene in an active way in the creative process. And this kind of setup has specific challenges. And the techniques you are exploring are quite inspiring for this kind of setups. I would like to ask you, in your opinion, what is the main barrier that this kind of tools based on deep learning can have in this kind of setups? We can imagine people composing together with machines, people improvising, performing with machines in this kind of setup, be it real time or not real time. In your opinion, what is the main barrier or barriers to the use of this kind of techniques in these setups?
Yeah. Thanks a lot. I think it's a very interesting question, also difficult to address in such a short time. But as you're seeing in the video, I mean, we have been using real-time audio analysis for trying to first automatize some visualizations of music. And then we also had humans to supervise or to complement, because sometimes the good thing about those tools is that they are complementary to human perception, in the sense that maybe they provide some details on the sound, some details that human cannot subjectively describe, but humans can complement that. So I think this complementarity between human and machine intelligence is the main challenge. And the main barrier we address, at least in our field in music, is to have meaningful interaction paradigms between machine and human intelligence. So in the past, we have tried somehow to, as I say, to automatize a little bit the human process, to provide tools. But I think we miss a lot of research on how to combine both. So how to take advantage of this complementarity between human and machine intelligence, this co-creation, how this co means. I mean, how can we have a human in the loop, human supervising? So I think the main challenge is more related to HCI and also human-computer interaction, and which are the best strategies for combining that. And the fact that until very recently we didn't have usable tools for this kind of system. We had tools that were only used by a technical audience or like very technical people. It was difficult for artists or for creators to use them, or for musicologists to use them. So you may have this kind of hybrid between musicology and an engineer that knows how to install Python, but usually it's very hard. So I think we require this human computer interaction and interfaces, and explore more the complementarity between both human and machine intelligence.
Thank you, Emilia. It was a very good answer. I think we have now questions from the public. There's a question from Ana Cantosalo. I would like to hear more about Emilia's views on research in academia versus research in corporate environments. You mentioned a mismatch between resources. Can you think of ways to balance out this difference, and of what should we think about, or what should we think about if we collaborate to shorten the gap?
Yes, I mentioned that there is a very different balance between academia, I would say big labs, and industry, and also academia. In terms, for instance, I mentioned computing resources, but also data, and I would say also access to real products, where real users that you may experiment with. So I think there will be, this is the reason why not all research can be done by everyone. So we need academia to find the research angles and the topics they are most, they have the most resources to do. So I really think there is an imbalance in some situations, especially in these deep learning environments where you need a lot of computing power and data. At the ISME community, for instance, we have trying to bring those two worlds. So I really think that we need more collaboration, because challenges of this kind needs both the industrial perspective, as I said, I was talking about interfaces, about collaboration, but also the academia side. So I think we can only do that by joining forces and having mixed teams that incorporate all the different views. And this is the strategy that we are trying to follow in our team, trying to collaborate also with industry. So I think there is a balance that should be done in terms of topics, and also I think collaboration is key for addressing the big challenges that we have now.
Okay, thank you, Emilia. There's another question from Gabrielle Viglensoni. I don't know if I spelled it correctly. Thank you for the talk. You mentioned, and I agree, that AI-based technologies may have an impact on jobs that can be described in simple words. What kind of music-related creative jobs do you think could be impacted with machine learning technologies?
I mean,
okay.
Yes, I mean, some examples. We work in our team in Barcelona. We do research, for instance, on singing synthesis. I played some examples of that, and I think there is, and also on music creation or music generation. So, in principle, as I mentioned, those tools might be supporting creators, but might be also replacing some of the tasks that we do at job. It's not the fact that singers will disappear or that composers will disappear, but they might have to work with those tools. So one maybe very radical example will be, okay, we have a platform, they have their creative tools and they compose their own music, and then we don't need to hire musicians anymore. Or this will be a radical example, as Gabriel asked. But my opinion is that AI tools will be impacting all the things that we do in our work, not really ourselves as a worker, but our tasks. So this is the approach we want to follow, that of course they will be assisting, but also influencing our work. So this balance of cognitive balance between our intelligence and their intelligence is something that we need to consider in the future. And we need to consider when creating our systems, we need to be aware that, I mean, sometimes we do it for the sake of scientific discovery or for fun, but this will have an impact also in music creators and how they work.
Thank you, Emilia. Good point. Question asked by Pedro Martins. I'd like to know Emilia Gomez's view on current state-of-the-art recommendation systems. Do you think there is much room for improvement?
I think, I mean, the current state of the art of music recommenders, I think it's very well advanced. I mean, there have been much research into that. I think we have workable systems in commercial platforms that then do their work. Improvement, at the moment, room for improvement. We are, for instance, interested in other aspects. Maybe now we are working on diversity of music recommendation and how this might have an impact also on our taste and also how we represent different styles. And so I think they're interesting topics that beforehand we couldn't address because we were very much trying to get to a good accuracy of those systems. And now we will be able to explore. So I think there's still room for improvement in terms of personalization, in terms of culture-aware system, in terms of diverse systems. So there is interesting work to do now in this field.
Thank you, Emilia. We are running off of time, but I think we still have almost 3 minutes, not quite 3 minutes, but almost to answer one more question. But after this session, we may join in the taberna, in the lounge room, okay, so that you can ask the following questions. There's still another one from Simon Colton, but I would put you this one to finish, okay, from Chip Jansen. I'm curious about how in MIR researchers balance objective and subjective evaluation of the music when creating annotated data sets.
Yeah, so usually in MIR data sets, we have objective metrics, which are metadata or computed descriptors, so they might say objective. And then we have subjectivity in the annotations. This is a very interesting topic of research that has not been much addressed. So we are currently working the topic of subjectivity. So we need to incorporate more knowledge from music psychology into this kind of annotations. So usually what you have is we tend to consider objective mostly, but step by step, the MIR field is incorporating the subjective annotations into data sets too.
Okay. Well, thank you very much, Emilia. All the questions not answered, for all those questions not answered, I invite people to go for a few minutes to the Taberna Lounge and meet there, like Simon Colton and all the others that want to join us there.
Yes.
Thank you very much, Emilia, for your participation in this conference.
Thanks for the
Congratulations
interesting question.
for your talk.
Yeah, thanks a lot to you.
Fun. Thank you.
Bye.
Bye-bye.
Hello. Oh, you're
Hello.
muted. You're muted, Dan. Hi, person. You're still muted, Dan.
Okay, how's that? Now I'm not muted.
Much better. Much better.
Hello.
Are we live now? Because we're 2 minutes early. Are we live, or are we just chatting
We're
amongst
just
ourselves?
Oh no, we are.
Oh, we're live. Okay. Well, hello everybody. Welcome to the show. Welcome to the session on performance. We have 3 papers represented by 2 authors at the moment, but I think maybe there'll be at least 3 authors and maybe 4. Perva, do you know if Debbie's joining us? There he is. There she is. Yes, Debbie's here. We're still waiting for Benedicta, who should be here in a second. And Oh, there she is. Great. Now we're all here. My name is Dan Ventura. I run the Machine Intelligence Discovery Lab at Brigham Young University, and I've been asked to host this session. We're very excited to have these authors with us today, and I think I'd like to start with just having each one briefly introduce themselves and maybe do a one-sentence introduction of their paper as well. And let's just start with Gopurva, Simon, Benedicta, Debbie.
Did you say we'll start with me?
Sure.
My name is Devi Parikh. I'm a research scientist at Facebook AI Research and an associate professor at Georgia Tech. And my paper here is with Purva as the lead author, so I'll let her describe it.
Great.
Okay. So hi everyone, my name is Purva Tendulkar. I just completed my master's at Georgia Tech, and at the moment I'm a visiting researcher at the University of California, San Diego. So this paper is about getting an agent to dance, interestingly, to any input music. And in this paper, we've kind of described an algorithm that is kind of more flexible in its way to do this. It's not about modeling human motions as such, but it's more about finding different movements that correlate to the music. And we've done a lot of analysis on that.
Thank you.
Hi, I'm Simon Colton. I'm a professor at Queen Mary University of London and Sensor Lab in Monash University of Australia. We have a paper in about creativity theatre, which is all about getting an AI system to perform while being creative so that it can actually exhibit creative behaviours. And the paper describes a way of doing that with casual creators and a motivation for doing that too.
Thank you.
Okay, hi, my name is Benedicta. I am a PhD student from the University of Oslo, and I work at a center called the Ritmo Center for Interdisciplinary Studies in Rhythm, Time and Motion. So the paper that I'm presenting today is a paper on exploring the use of sound features to affect the way a movement generation model generates dance movement.
All right. Hopefully we get some audience questions here, but I'd like to start off with a couple myself that I thought of. I would like to plug the videos for everybody in the audience. All three videos for these papers were just textbook examples of how to do a really entertaining, informative, polished video. The work's really interesting, but have a look at the videos especially. They're really great. Here's a question I'd like to throw out to all the panelists, and maybe if you could keep your answers brief, but just have everybody address this question. Why would we want, this is sort of a devil's advocate question maybe, but why would we want to have CC systems or artificial systems doing performance? When you might argue instead that performance is a very human activity.
Simon, you want to go ahead or should I go ahead?
Oh, no, please go ahead.
So I think that in today's day and age, AI is, or yeah, in general, computational systems are kind of going to become a part of our everyday life, and they've already started becoming. So I think there is some need for humans to kind of like the systems that they're dealing with and have some kind of, I mean, these systems are going to be taking a lot of decisions for humans. So I kind of think of computational creativity or dance as kind of a way of engaging humans more with these systems. And like you said, like dance in general is more of a human thing, but if you have this fun agent that can dance with you or dance to some tune, you might find it maybe more interesting, more trustworthy to some extent, and just more likable. So I was thinking of it more from that angle.
Yeah, I can second that. I think also creativity as a way of humanizing the way we interact with machines in general. That's also a big focus in my work, is this sort of human-computer or human-robot interaction and things we can learn about these traditionally performative things, and having an AI do this in a way which is interesting and realistic I think definitely contributes to our perception and trust with virtual agents. Yeah.
And I think another perspective here also is that even if it is the case that creativity is sort of a very human activity and a human endeavor, I think machines could augment that, right? Like it could be a source of inspiration, or if it's a collaboration between a human and a machine, then the creative process could be more engaging, more satisfying for a human. The final artifact might be better in some way. And so I think the machine can be a part of that human experience as well, which could be interesting.
Simon, your paper's a little bit different than everybody else's in the angle that it takes with performance. Can you say something about that?
Sure. I mean, you really are being devil's advocate here, because you've worked with me on a system where a hand appears on screen and paints a picture using your material in the background. And we did that for public engagement purposes. This is a Painting Full project from a decade ago. And it really does help people to engage with the idea that the software itself could be creative. We used to, you know, leave it running, and it's not enough for people to engage with it if they just see the output. So there's a working definition of computational creativity, the research field, by Geraint Wiggins and myself, where we talk about behaviors taking on creative responsibility. And most of the time you don't get to see these behaviors. I mean, there are good exceptions, but if you don't see the behaviors happening, then you're going to have to read our technical papers in order to find out what's going on, which the general public are not going to do. Or you're going to have to try and reverse engineer the notion of creativity from the artifacts produced, which is difficult and probably impossible to do. So from my point of view, getting one AI system to perform the kind of creativity on top of another generative system, which is what we promote or pitch in the paper, really does help with public engagement. And really, creativity is a community-owned, it's a worldwide owned notion. So if we don't get feedback from various stakeholders, including the public, artists, and you know, audience members, then we're not going to really nail down what creativity is in order to automate aspects of it.
Great, thank you. Let me keep talking to Simon for a second, and let me ask this question. Could you, your system, the system that you described in the paper that you're just presenting here, performs not for the purpose of performing per se, but or to entertain with the performance, but rather to convince the audience that it's being creative, right? Go ahead.
Well, it's a bit more nuanced than that. So when we go to a human poetry slam, part of the entertainment is absolutely seeing that person be creative live on stage. Same with jazz musicians jamming or improv theatre. So it's not the opposite of entertainment or just not entertaining at all. I used to watch my piano teacher compose at the piano, and it was wonderful to watch her be creative, and that's always stuck with me. So in the paper I say that there's so much of human creativity theatre already out there. It's part of the genre in many cases. That it's a shame that computers don't do it. And yes, it will help if managed correctly with elements of drama and performance. And we go into a little bit of detail about that in the paper to get across this idea that the software is actually being creative, if you can see it being creative. And why not make it entertaining, like we did with the hand on the screen, so that people will actually engage with it rather than being put off.
Excellent. Let me ask a paired question now for Benedicta and Purva. Your papers are similar in what they're trying to do, and they're sort of complementary in how they do it. I'm going to go out on a limb and assume you've had a look at each other's work, and maybe if you could both say something about how you see your work relating to the others, how they're complementary, how maybe they are similar or different, or whatever you want to say.
Should
Sure.
I go ahead first? Okay. So I found, is it Benedicta? Am I pronouncing it right?
Yeah.
So your work is very interesting. I think they're similar in the fact that you want to have some kind of an agent. Like in her case, it is a humanoid. In our case, one of our examples is a humanoid, but we've also experimented with some other visualizations. But I think the core idea is similar in that you want it to be able to move in interesting ways to the music. It's different in the sense that she's explicitly, I think, modeling human joints and taking experience from different dancers. In our case, I think our focus was more on the music and explicitly modeling it, not based on any humans, but rather based using the music itself as kind of like a supervisory signal, so that we can learn about what movements to take just based on the music. And I think I personally would be interested in just seeing where both of the works would kind of come together, honestly, where we can kind of combine music as well as human feedback and just see if a combination of these two might lead to something interesting. So after reading her paper, I kind of felt like some work at the intersection of the two would be really interesting.
Yeah, I absolutely agree with that. I thought it was very cool, especially as you mentioned in your work, not necessarily working with a humanoid agent. I think that's very, very interesting and sort of makes you look at movement in a wider sense than I do in my work specifically. I think also one of there are many hurdles with using supervised learning techniques to do something which is creative, which is, I've had already in this conference, had some good discussions about this, because it is sort of a pet peeve of mine, or like something I've been struggling with or battling with since I began this work, and even in my master's, the fact that I'm sort of trying to tell the model to improve its dancing based on a set of examples. But of course, there are a myriad of ways that could be equally interesting. So calculating some sort of error term and having a neural net update itself based on how similar it is to the movements in the data set is not really bringing me any closer to what I really want, which is sort of exploring the context of like what kind of structure could model this creative behavior, because I'm restricting it as per definition, which I also thought then reading your work and looking at what you guys do, that there are some interesting ways of bringing the two together. And I was very curious to see, because I see you mentioned in your future work that you maybe wanted to do some more ML related stuff, and like how you see that becoming part of this system. And yeah, so I thought it was very, very interesting, and definitely some cool overlap there.
Debbie, did you want to add anything?
No, I think that covers it. Just one point related to what Benedicta you were saying, that in the context of machine learning, and I agree with your complaints about how supervised learning is set up in the context of creativity, but that's where maybe something like reinforcement learning could be interesting, where you still have some reward signal, you're still trying to optimize for something, but not through examples that already exist, and so there is scope for finding something new that might be creative.
Yeah, I'm definitely looking at that and have been, and it's sort of a you want all the things. I want the things from both worlds. Like I like you can get some really cool like well-defined sort of contours over time, this sort of long-term dependencies, which sequence learners and supervised learners do really well. But then when you try to you sort of either get something which I do discuss to a little bit in the paper, is that the results can often become sort of deadpan versions, overgeneralized versions of what I see in the data set. So if you then step away from that and try to sort of sample more stochastically or using different techniques to get more of a randomness into the sampling, then you very quickly move over to the other extreme, and it becomes the dance equivalent of free jazz, and it can have like it can be a little bit too